So today we are going to learn to draw shear force diagram and bending moment diagram of beam. There are many type of beam. We are considering the case of cantilevers. Cantilever is a beam supported at one end, hinged at one end, and in this case, in this specific case, we have got a beam AB and we are applying point load W at point B. We are considering a section X, this section X, for the analysis. We are going to learn how to draw shear force and bending moment diagram for it. And now the sign convention for it would be this. Just now I am representing sign convention with these diagram. Later on I will explain it in detail in the words. So for the sign convention, bending moment left side clockwise we will take positive, shear force left side up we will take positive, and right side up shear force we will take positive, and bending moment right side anti-clockwise we will take as positive, and opposite to this we will take negative things. So let us consider first a beam AB of length L subjected to a point load W at the free end, and we are considering for the analysis a section at distance x from B, at distance x from point B. So let us sketch free body diagram for this section. Here it is free body diagram. We have removed this side of beam. So to counter this load W, opposite load V, we are marking it here, and to counter this clockwise bending moment, to counter it we will apply a bending moment M. We will use subscript Vx and Mx for the section X. So shear force at any distance using this sign convention would be, let me write it, shear force would be left side up is positive, so Vx okay, shear force is written, and now W is down, so minus W is equal to 0. So how much is Vx? Vx is plus W. So for this section Vx is plus W, and for the rest of beam, as no load is applied in between, it will remain same. So Vx will remain plus W. So how its shear force diagram will vary? It will vary like this. It will remain constant throughout the beam and its value will be W. As X is from 0 to L, the shear force will remain constant as plus W. Now we will see bending moment. Bending moment at any distance X would be this bending moment M would be in the minus direction. As per our sign convention, its direction is opposite to the sign convention, so we will use minus sign, and when we reach to this point, the bending moment will be W into X, and that would be again downside minus direction minus W into X. So M will be equal to 0. M would be equal to minus Wx minus Wx. So at x is equal to 0, at x is equal to 0, bending moment will be at B point. Bending moment at B point would be equal to 0, and at x is equal to L, bending moment, we will reach to point A when x is equal to L, so bending moment will be equal to W into L minus W into L. So our bending moment diagram, at B point W will be bending moment will be 0, and at A point bending moment will be minus W L, and in between at any point, at any point x, bending moment will be minus W into x. So this is how we are going to use this sign convention, and in the next example I will use different sign convention. So let me delete it here. This will remain same, and let me delete all the things. Just I am deleting the values. So now the sign convention we will be using will be, I am deleting this sign convention and will be using this sign convention. So shear force at any section x would be equal to, this shear force is V, and we know the sum of all the forces are E0, and this sign convention is positive, downside is positive. Now according to this sign convention, you must remember that I have changed this diagram, plus W equal to 0. So V at any section x will be equal to minus W. Minus W will be constant for the whole beam. As we can see, we have applied for W here, and no other force is applied anywhere in between, so no force change will take place, and the shear force will remain constant for all the whole beam. So how the shear force diagram will behave is drawn here. Shear force, this is our beam, shear force will be minus W for the whole beam. And now we will see bending moment diagram. Just I have to write it here. Now we will see bending moment. So bending moment at point x, this bending moment is in this direction, so value will be minus. Now we will reach at this point, so W into x, and that also is going to be minus, as this sign convention is in negative direction, so minus W into x equal to 0. Sum of all the moments should be 0. So m x equal to minus W into x. This is basically subscript, so we don't confuse it with into distance into x. This is subscript this is also subscript. So bending moment at any section x will be minus wx. Just put it here, minus wx. At x is equal to 0, bending moment will be equal to 0. At x is equal to L, we will get the bending moment at A point. This is the B point. MB will be equal to 0. At x is equal to L, bending moment will be equal to minus W into L. So we can see the bending moment will remain in negative direction starting from 0, and it will vary up to minus WL. So this is all for this lecture. We will take another examples for different problems.